database management and warehousing. So this is the module gives us a basic foundation course in order to develop skills for data scientist. So this is the core and first and foremost important core subject for data science. Here we are covering the syllabus like introduction to database management and how the evolution of a database started, and entity relationship model, how it is useful for diagrammatic representation for solving the database applications, and how to use relational model for creating a tables, databases, and how do we use relational algebra in order to develop logics and mathematical representation in order to efficient utilization of memory, and tuple calculus. Tuple is nothing but a relation or a table or a procedure or instance. You can call it as an instance or records. Then how do we use tuple calculus in order to develop logics for creating a tables for effective memory utilization? Then followed by the structured query language. How many types of languages we are studying, like DDL, DML, and DCL, TQL, etc. Data definition language, data manipulation language, etc. Then what are the integrity constraints we are using in order to effective utilization of memory in the database? Then normal forms. So why we are using normal forms? In order to reduce the redundant tuples, redundant rows, redundant instances, or in redundant information. We are having a first normal form, second normal form, third normal form, BCNF, fourth normal form, and fifth normal form. These are the types of normal forms we are using. Then followed by the file organization. File is nothing but collection of related data, and we are storing in the form of text files and binary files. Then followed by the indexing. So how do we use indexing positions in order to store the data or tables in a system, server, or data center? What are the data types we are following in order to access easy access of any kind of data like audio, video, text, graphics, animation, etc. Numeric data, text data, character data, etc. Then followed by the data transformation, like we are converting one file format to another file format. Then what is data warehousing? So storing of a huge volume of data with help of data cubes. We are storing a huge volume of data in the system, server, and data center. And what are the modeling and the schema for multidimensional data models we are using, like star schema, snowflake schema, fact constellation, etc. And what are the concepts of hierarchies and measures, categorization and computations we are using in order to develop a database? Then if you see the first concept what we are covering in this introduction to database management system. So the practice of managing data in a structured and efficient manner. If you are using a relational database language like SQL, MySQL, Teradata, DB2, MS Access. These are the relational database tools, languages based on the schema, based on the procedure, based on the relation. We are creating the table. Table consists of rows and columns. Collection of tables is called a database. So based on the schema procedure, we are calculating, we are creating the tables. So that's why we are managing data in a structured and efficient manner. There are three types of data we are using in the real-time environment: structured data, unstructured data, semi-structured data. Structured data uses relational database tools based on the schema, procedure, and a relation. We are creating the tables like SQL, MySQL, Teradata, DB2, MS Access, etc. And unstructured data is nothing but there is no schema, there is no procedure, there is no table, but we are creating the database with help of NoSQL databases. That means non-relational database languages such as Mongo database, Hive database, HBase database, and Scoop, etc., Cassandra, etc. So examples of unstructured data like audio, video, text, graphics, animation, etc. Then followed by the semi-structured data is nothing but 50% of structured data and 50% of unstructured data we are using and creating the database. Best example for semi-structured data is XML database. Then followed by the concept like it involves storing. Why do we want to use database management system? So we are storing the data, we are retrieving the data, and we are manipulating the data through database management system, nothing but SQL, MySQL, Teradata, DB2, MS Access, etc. Then what are the types of databases are there? There are various types like hierarchical databases and network related databases and relational databases, object oriented databases and NoSQL databases. So object oriented is nothing but everything we are dealing with the real time applications, real time entities like classes and objects, and followed by the various pillars of object oriented programming features like data abstraction, data encapsulation, inheritance, polymorphism, and exception handling. So, so based on our requirement, we are choosing the programming language like Python or Java or JavaScript or etc. NoSQL databases like non-relational databases. That means there is no schema, there is no procedure, there is no relation, but we are creating the database with the help of NoSQL databases like Mongo database, Hive, HBase, Zookeeper, Cassandra, and Scoop, etc. Then examples like Mongo database is a NoSQL database is used for storing JSON like documents like audio, video, text, graphics, animation, etc. Then second concept we are dealing with the ER model, entity relationship model. How do we use flowchart, data flow diagram, unified modeling language diagrams for different programming languages like C programming uses flowchart. Flowchart is a graphical representation of a problem or diagrammatic representation of a problem. And if you see the object-oriented programming languages like C++, Java, we are using DFD diagrams, data flow diagrams, or in order to solve real-time applications, we are using a unified modeling language called UML. There we are using various kinds of diagrammatic representation languages like use case diagram, sequence diagram, object diagram, class diagram, and activity diagram, state chart diagram, and deployment diagram. These are the various industry oriented unified modeling language diagrams we are using. Why we are using? In order to understand what is the problem statement, what is the sequence of steps we are following through a state chart, through activity chart diagrams. That's why diagrammatic representation plays vital role in order to understand any real-time applications. That's why we are using in database languages like ER model, entity relationship model. Entity is a characteristic of an entity like a student having many entities like student name, student address, student mobile number, student marks, etc. So a blueprint for designing a database or depicting entities and relationships between number of attributes or number of entities. That is called a entity relationship model. So it is useful for visually representing, means diagrammatic representation is easy to understand the problem definition, sequence of the steps, the the various entities and the relations in a database. For that purpose, we are using ER model. There are three types of ER models we are using: conceptual ER models, logical ER model, and physical ER model, entity relationship model. Then examples, if you take in a library systems, the way we are arranging the books and the reader or entities and borrows is a relationship between number of books and the number of readers. So that is we are representing through diagrammatic representation. It's called ER model. Then see, the third concept is relational model. Model is a nothing but a simplified version of the reality. That means through diagrammatic representation we are showing and explaining the concept. So if you are maintaining any relations between that model, it is called a relational model. That model that structures data into predefined relationships, means there is a schema, there is a procedure, there is a relative, there is a syntax. Based on that syntax, we are developing the tables. So generally in the form of tables. Tables is nothing but collection of rows and columns. So tables consist of rows and columns where each row is a record and each column is a field. So columns are playing a vital role in order to find out the time complexity based on the columns. Because if you are increasing the columns, that means automatically the system becomes complex. So, so there are types like relations, like tables. Tuples means rows and attributes means columns. So attribute is nothing but a characteristic of an entity. So attributes are playing a vital role in a table. Examples like a products table could have attributes like a product ID, product name, and price. This is the best example for relational model. If you go to supermarket, we are purchasing the products and we are maintaining the table called products table. There we are mentioning the attributes like columns, product ID, product name, product price, etc. Then the fourth concept is relational algebra. So relational algebra is nothing but a mathematical formal system for manipulating relations like tables. So a set of operations that can be performed to retrieve or accessing the data and manipulating the data with help of relational algebra. So types like select, project, union, set difference, Cartesian product, intersection, etc. These are the relational algebra types we are using. So example like select, we are using sigma symbol. Price greater than 50 products would select all products with a price greater than 50. This is a relational algebra representation of database. Fifth one is a tuple calculus, like a mathematical procedural query language dealing with the tuples. Tuples is nothing but relations. Relations is nothing but number of rows. Number of rows is nothing but instances. Instances are also called as records. So it allows the selection of specific tuples based on a given condition. There are two types of tuples we are dealing in the real-time environment: existential calculus and universal tuple calculus. Example, if you take flower brace begin T dot product name or T belongs to products and T dot price greater than 50, we are closing the closing bracket. This is the way we are using in order to perform the tuple calculus. Then the sixth concept is structured query language. So in this structured query language uses various database languages like SQL, MySQL, Teradata, DB2, MS Access. These are the relational database tools. One among this is SQL. It is a programming language, database programming language used for managing relational databases. Examples like it enables creation. Yes, we are creating the table, we are modifying the table, and we are querying of relational databases. And types like data definition language and data manipulation language and data control language. For example, we are performing the products table like this. I would like to delete from products where price less than 10, so this is a query I am asking from the products table. So whatever the items are less than 10 rupees, we are deleting from the product table. Then if you see the seventh one, integrity constraints. That means if you would like to integrate with the number of tables, number of relations between tables, and we are applying some rules to maintain the accuracy and integrity of data in a database. So for that purpose, we are using integrity constraints so that we can access database very easily. So integrity constraints ensure the database remains consistent and error free. So types like primary key, foreign key, unique, check, not null. These are the types of integrity constraints we are using in order to perform user requirements and in order to perform and merge and modify the tables according to user requirements. We are performing the various integrity constraints. Example, if you check check A is greater than or equal to 18 constraint on a user's table. So we are checking the constraint like A is greater than or equal to 18 means they are eligible for voting system. Then eighth concept is normal forms. So normal forms is a set of criteria used to evaluate the design of a relational database. That means we are removing the noisy data, inconsistent data, redundant data, dirty data with the help of normal forms like 1NF, 2NF, 3NF, BCNF, fourth normal form, fifth normal form. And a normal form designed to minimize redundancy and dependency by organizing data. So example, a table is in third normal form if it's in already satisfied the first normal form and second normal form and has no transitive dependencies. That case is called third normal form. And the ninth concept is file organization, indexing and data types. What is file? File is a collection of related data in the form of text data, that means binary data and text data. How data is stored on a disk, that is decided by the file organization. Indexing is nothing but it is a data structure for fast data retrieval. That means index starts from 0 to n minus 1 if you are using arrays concept or hash table. Based on the key value pair, we are using the hash tables and we are retrieving the element based on the index position. What is the great advantage of indexing? Within order of one iteration, we are retrieving the element. That means order of one is the time complexity. That is the great advantage of indexing. And remaining all are drawbacks of indexing concept. Then data types, like define the data types of data. What type of data we are dealing, like binary data, text data, audio data, video data. Based on that one, we are using the data types. There are three types of file organizations like file efficient storage for quick access, indexing and data types. So file organization, why do we want to use? In order to efficient memory management, efficient storage for quick access, we are using file organization. Indexing is nothing but speeds of query performance. Order of one iteration, we are retrieving the element from the database. That's why we are choosing the indexing concept. There are various types of file organizations like ensures correct and efficient data storage we are using. And what are the types we are using? We are using three types like file organization like sequential files, indexed files, and hash based files. So sequential files we can access sequence of files. Indexed files we are accessing based on the index positions. Hashed file organization means based on the key value pair we are accessing the elements. Then indexing is nothing but based on the index positions we are inserting the elements. Indexing starts from 0 to n minus 1. There are various types like single level indexing, multi-level indexing, clustered level indexing, and non-clustered level indexing. So data types we are using in the file organization like integer, string, boolean, date. If you take example like a B tree, B stands for most of the common belief in the human being. B stands for belief. B tree is a binary search tree. Binary search tree is a tree, and the left subtree is always less than the root, and the right subtree is always greater than the root. If it follows that rule, that is called binary search tree. How do we justify the constructed binary search tree is true? Based on the in order traversal, the way we are getting the elements in a ascending order. So B tree is a binary search tree. It is used for index on a date of birth column for faster lookups like B tree having properties like all leaf nodes at the same level, and for best memory utilization purpose we are using B trees and B plus trees. And the last but one concept, data transformation, is nothing but we are conversion of one file to another file, like the process of converting data from one format to another format. Like suppose we have a Excel sheet. So .xls is extension of Excel file. I'm converting into CSV. CSV is nothing but comma separated variable. So usually data transformation carried out to a clean and aggregate and enrich data. For that purpose, we are using the data transformation. Types like cleansing means we are eliminating the noisy data, inconsistent data, redundant data, dirty data with the help of cleaning. Then aggregation, group of classes, group of data is nothing but aggregation. Normalization is nothing but we are eliminating the redundant data. Example like converting a set of date strings from DD, YYY. So it is a British representation of date of birth. If you take American, so American other systems they are using year, month, and data and date. So this is one type of general problem we are converting into one format to another format so that we are giving input to the system. That time it cannot reflect any wrong kind of data output. Then the 11th concept is data warehousing model and schema for multidimensional data models. What is data warehousing? Data warehousing is used to store a huge volume of data in system, server, and data center with the help of data cubes. Data cubes is the measurement of storing of huge volume of data. And it is an architectural model for building data warehouses. and it helps in storing large volume of data for analytical purposes. In order to generate interested patterns or analytics, we are using this data warehousing modeling and schema for multidimensional data models. There are various types of multidimensional models like star schema, snowflake schema, fact constellation. Examples of using a star schema with a central sales table linked to customer and customer class and customer table, product table, and time dimensional tables. So likewise, we are representing multi-dimensional data models. So the 12th concept is concept of hierarchies, measures, categorization, and computation. Why do we want to use concept hierarchies? Levels of abstraction or aggregation in data. So in that case, we are choosing the hierarchies. Measures like quantitative metrics used for analysis, like cost, total, total number of items, okay, count, maximum, minimum, average, standard deviation. These all are the measures, quantitative metrics used for analysis. Like concept hierarchies like provides a drill down or roll up view. These are the operations of a multidimensional uh, models, like measures like facilitates calculation and data insights. The types like concept hierarchies like geographical, time-based, and organizational hierarchies. So measures like count, sum, average, min, max, examples. So these are the multidimensional quantitative metrics used for analysis. Example like concept hierarchies. We are we are living in city. The city is in state. The state in which country? The country in the world map. So what are the measures? Calculating total revenue by summing up individual sales. This is about the concept hierarchies, measures and categorizations and computation. So if you see the database management and warehousing, so here we are using, it is a backbone for creating the table, creating the database, managing the database, and analyzing structured data sets in the world of databases and data warehousing. So in this data management warehousing, we are using introduction to database management. So it involves the use of specialized software called a database management system, that is called database DBMS. That means to store the data, to retrieve the data, to define the data, to manage the data in a database with the help of SQL database software or MySQL software or DB2 software. It is a product of IBM company, and SQL is a product of Oracle company, and MySQL is a product of Microsoft company, and Teradata is a product of Teradata company. And this data is consistently organized and remains easily accessible. So database management system are software systems that allow you to create the data, manage the data, and manipulation of databases. Example like MySQL, PostgreSQL, and Oracle are examples of DBMS. An ER model, entity relationship model, is a conceptual way of representing data structures. In a library database, book and author could be entities, and an author writes book could be a relationship. Relational model called the relation model represents data as tables, that is called relations. Example like a student table with columns student ID, first name and last name. Relational algebra. I have explained already. Relational algebra provides a set of operations to manipulate tables. Example select operation to choose rows, project to choose columns. Tuple calculus. Tuple calculus is a query language for the relational model focused on tuples. Example like flower brace. T of t belongs to student and t dot e is greater than 21. Flower brace close selects all students older than 21. SQL structured query language is used for interacting with a database management software. Example like select first name from student table where age is greater than 21. Then integrity constraints I have explained. These are rules that the data in the database must adhere to follow the integrity constraint for maintaining the consistency. Example like a primary key constraint ensures uniqueness. Normal forms, these are design and guidelines to eliminate redundancy and inconsistency. That means we are eliminating the noisy data, redundant data, inconsistent data, dirty data, etc. For that removal purpose, we are using one NF, one first normal form, second normal form, third normal form, Bayes code normal form, BCNF, and the fourth normal form, fifth normal form. Example, in third normal form, every non-primitive attribute is functionally dependent only on the primary key. File organization, indexing and data types, how data is stored on disk, how indices are built for fast retrieval, and what kinds of data can be stored. Like example, B trees are often used for indexing. Data types can include int, varchar, etc. Then data transformation I have explained. Process of converting data into a suitable format. So normalization and denormalization are forms of data transformation. Examples. Data warehouse modeling and a schema for multidimensional data models. Like a data warehouse stores data in a format optimized for querying and reporting the data. Examples like star schema and snowflake schema are popular data warehousing schemas. The final concept is concept hierarchies and measures. So what are the categorization and the computations? In data warehousing means storing of huge volume of data. The concept hierarchies and the measures helps in analysis. In a sales database, take example, in a sales database, the concept hierarchy could be region, country, state, and city. So measures could include total sales, average sales, etc. This is example for concept of hierarchies and measures. So database management and data warehousing. So DBMS is a to manage the database. We are using various database management softwares like SQL, MySQL, and Teradata DB2 MS Access. So I have explained already introduction to database management system, ER model, and relational model, relational algebra. See, once again, I'm explaining. So what is ER model? ER model is a
Yeah, I
mathematical.
think you already explained. You can
Yes,
skip it.
yeah,
Skip it.
I have explained. So these things I have completed. And now we'll solve a 5 minutes quiz. Which
Tuple.
of the following is a property of a database? My screen
Mm,
is visible, Sundar.
yeah, yeah, I can see D, all of the
Yeah,
above.
please. Yeah, all of the above. Perfect answer because the database has to satisfy the atomicity, consistency, and the isolation. This
Yeah.
is for refresh for you. I think all the concepts you know very well. Just I'm reminding the concepts. Then in an ER diagram, an entity set is represented by whether it is ellipse, rectangle, diamond, and triangle. What
Uh,
are the in ER
Entity
diagram we are
rectangle
using?
D.
Yes, perfect answer. Rectangle. Then in a relational model, relations are termed as whether it is tuples, attributes, tables, and rows. I'm asking the question relations. What is meant by relations?
Uh,
Relations is nothing but in a relational model, relations are whether it is
is it
tuples or
you said
attributes
like a
or
tuples means like a
tables.
rows, right? You said tuples means rows. It should be attributes, right?
Relations are tables. So
Oh,
attributes, yeah, tuples means you can call it as a instances,
yeah.
records.
Okay.
Yeah, yeah, yeah. Table is a collection of rows and columns. Same way relation is a
None attributes. Okay,
collection of
got it. Yeah, it
exact.
gets all three. Okay.
Yeah, yeah. The union operation in relational algebra is commutative, associative, both and none. Union usually it combines from
You
one table
combine
to
both.
another table. Yeah.
It
So both perfect answer, Sundar. Then tuple calculus is a dash query language. We are using tuple calculus
is a
and
procedural,
relational
right?
calculus.
Is it
We are using.
procedural?
Yeah. So we are using a tuple calculus is a non-procedural query language. Then sixth question is which SQL command is used to insert a row in a table? Whether it is
Insert into.
add, insert into, update and modify.
Be
Perfect answer.
insert into. Yeah.
B is insert into. Next, then a not null constraint ensures whether it is data integrity or referential integrity or domain integrity or all of the above.
D.
So not
All of
null
them.
constraint is a domain integrity. Means
How
which
is that?
domain?
I mean, it could be data integrity, it could be
Yes.
reference too, right?
Yeah, perfect, perfect. And which normal form focuses on removing partial dependencies. So we have 1NF, 2NF and 3NF and BCNF. So non-trivial is different and removal partial dependencies in a second normal form. Yeah, then ninth bit is a B-tree index is preferred over a hash index when a B-tree index is preferred over a hash index when.
You
Then,
see,
yeah, searches are mostly quality searches or range queries are often used both A and B or none of the above. Range queries are often used in the case of hash index. Means based on the key and value pair we are arranging the elements. There is a concept called hashing function. Hashing is the process of mapping key with value modulo division operation we are using. That means we are getting the range queries are often used. ETL in data warehousing stands for. There is a famous tool in data warehousing, Informatica. You might heard. Informatica is a data warehousing tool in order to perform the data transformations and aggregation operations.
yeah, extract
Yeah,
transformation
yeah,
and
extract, transform and load. Perfect answer. So nowadays we are not using ETL tool. We are using various high level
we are, in a
data
big data, we're
warehousing tools
using
like Hive
ELT.
and HBase. Yeah, perfect answer. Hive and HBase we are using nowadays. So this is extract, transform and load. Then a star schema consists of, see there are multidimensional models like star schema, snowflake schema, fact constellation. So in
So
order
yeah,
to represent the
one fact table, multiple dimension.
one fact table and multiple dimension tables, perfect answer. And 12th one is a snowflake schema is a normalized form of star schema or
Yeah.
fact table and both A and B and none of the above.
And C.
Yeah, snowflake schema is a normalized form of just a star schema. Star schema is a combination of one fact table and multiple dimensional tables we are using. Then the 13th one, concept hierarchies are primarily used for why we are using data summarization, data transformation,
Summarization. Yeah.
loading, data extraction. We are using concept hierarchies are primarily used for data summarization. Perfect answer. 14th bit, which measure is typically used in OLAP? OLAP is nothing but online analytical processing. That means data warehousing, means legacy data, old data. We are dealing with the system. So there we are using what type of measure? Measure is nothing but
Yes.
quantitative count, like sum, it may be count, it may be average.
D,
Yeah,
all
it,
and above.
all of the above. Perfect answer. Then in a data warehouse, the time hierarchy can be so day tends to month, month tends to year, or year tends to month, or tends to day, either A or B, or none of the above. Both A or B is the
Yeah.
correct answer for in a data warehousing. The time hierarchy can be represented as. Then which SQL keyword is used to filter aggregated data? Where, filter,
Having
having,
C.
select.
C is the right.
Perfect answer, Sundar. You have given outstanding answer called having. Having is a keyword is used to filter aggregated data. Then 17th one, in a relational database, a field is also known as field,
Attribute.
like tuple, row,
Attribute.
attribute, record. Perfect answer, attribute. Attribute is a field in a relational database. Then 18th question, the process of defining relationships between tables in SQL is known as
Joining.
joining, linking, mapping, and referencing. Perfect answer. The process of defining relationship between tables in SQL is known as joining. Then the 19th bit, a full backup of a database. What is the meaning of a full backup of database? It backs up only the structure, backs up only the data changed since
C.
the
To back
last
up the
backup.
structure and data.
Yeah, backs up both the structure and the data, none of the above. So it backs up both the structure and the data. Then the last bit, a column specified as a primary key. So what is the meaning of a column specified as a primary key? Must contain unique values,
And
cannot contain null values, both
C.
A and B,
C.
and
Both A and
none
B.
of
Yeah.
both A and B. Perfect answer, Sundar. So which of the following is not a basic ER model attribute? Like composite, derived, single valued, and homogeneous. So which is not a basic ER model? See, remaining all are except homogeneous, remaining all are ER model attributes, like composite is a attribute model, derived is a attribute model, and a single valued, and which is not a basic ER model attribute called a homogeneous.
What is homogeneous means?
Homogeneous is nothing but same type of elements representation in a database. That is called a homogeneous.
Yeah.
Not, yeah. The projection operation in a relational algebra selects projection. We are using columns, not rows, not both rows and columns, none of the above. Then a tuple calculus is a data definition language, data manipulation language, and a query language,
I think
and
query.
none of the above. It is a tuple calculus is a query language. Perfect answer. Then which SQL constraint ensures that all values in a column are different? Which SQL
Unique.
constraint ensures that all values in a column are different? It is
Unique.
unique or primary key and foreign key and not null. Unique. The A is the correct answer. Which normal form requires the elimination of partial dependencies? So 1NF, 2NF, 3NF, BCNF,
Two.
2NF. So we have seen this bit earlier also. Then a B tree of order M has all leaf nodes at the same level. This property is called, is it
Balance.
balance or completeness or depth equality? None of the above. Balance. A B tree, most of the people believing that B stands for balance. It's a common belief. Keep in mind, there is no expansion. B tree stands for balanced tree. No. But most of the people common belief is that they are believing that B stands for balance. That's all. And which data type would best represent a person's age in a database? It is a float or
Integer.
int or char or varchar. Int. So person's age means numeric. 20, 30. My age is 45. So I'm representing through integer data type. So in a star schema, in a data warehouse, the fact table is usually, it is normalized
Denormalized.
or denormalized or indexed or all of the above. Denormalized, perfect answer. Then the 29th, which of the following DBMS types is most suitable for analytics and complex queries?
OLAP.
So yeah, we are using online analytical processing. OLAP stands for online analytical processing. It is a old database. It is a legacy database. So in order to extract a 10 years old database, we are storing data in the OLAP. OLTP is there, online transaction processing. That means current
Transaction data.
database
Yep.
and current transactions we are performing. In an ER diagram, which symbol is used to represent a relationship? So we have got this bit already. We are using diamond symbol. So in an ER diagram, which symbol is used to represent a relationship? Diamond. So what is the maximum number of tuples that a relation R of A comma B comma C can have if a domain of A equal to 10, domain of B equal to 10, and a domain of C equal to 5? So what is the maximum number of tuples? Means tuples means instances or relationships, or I mean tuples, you can call it as a number of rows,
Rows.
number of columns, number of instances. So it is
Yeah.
500. Okay,
10, 10,
500
yeah,
instances.
multiplication of
Yeah,
A, B, and C. Yeah.
yeah, perfect. Then which relational algebra operation is not commutative? That means we are using a set difference is the relational algebra operation. Remaining all are relational algebra, like we are using union, intersection, Cartesian product. These all are a relational algebra. Okay, but except set difference is a commutative. Then which of the following tuple calculus expressions retrieves all tuples in the student relation? So which is the correct answer? So B is the correct answer. That means all, we are accessing the all tuples in the student relation. That means flower brace begin T or, so there exist. Yes, I mean S stands for student, belongs to students of T equal to S. Number of tuples means rows equal to number of student relation. Then what will be the output of the SQL query? Select count distinct age from students table where age greater than 20. If the ages in the student table are, how many are there? Greater than
25.
20. Yeah.
Oh, sorry.
So we
Sorry.
have
No, 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 no,
no, no,
no. Three. Yeah.
21,
Sorry.
21, 22, 23. Three elements are there
Yeah.
greater than 20.
Three greater than. Yep.
Which integrity constraint ensures that a foreign key value has a matching primary key value in the related table? We have a referential integrity constraint. So which integrity constraint ensures that a foreign key, we are using foreign key value has a matching primary key with the help of referential integrity constraint only. Then a relation is in second normal form if it is in first normal form. What is that meaning? What is the first normal form? All non-prime attributes are fully functionally dependent on the primary key. So that means if it is second normal form means it satisfies a first normal form. What is first normal form? All non-prime attributes are fully functionally dependent on the primary key. Of the following index type is most effective for range queries. So we are using a B tree index for a range queries. If you want to perform, all leaf nodes are in the same range, same level. That's why it is called most effective for range queries. Then which of the following methods is not used for data normalization? Not means Hoffman encoding. Remaining all are data normalization methods like min-max normalization, z-score normalization, decimal scaling. So Hoffman encoding is not used for data normalization. In a star schema, what is the central table that contains the facts and measures of the business process? So fact
Fact table.
table. Then in a data warehousing, which of the following aggregation types can be calculated for a measure? So measure is nothing but quantitable element like sum, count, average, minimum, maximum. So these all are, you can call it as a aggregation types can be calculated for measuring the elements or measuring the database. So with this one, 40 bits we have completed. And with this one, I'm closing database management systems and data warehousing, all the concepts. Sundar, please stop the record. So we will wind up